This video goes through some more applications of quadratic equations. It's just a set of worked problems where quadratic equations are useful. So here's one example. It says 3x minus 19 is one side of a triangle, x minus 3 is the other one, x minus 4, and 4. Sorry if that's a little unreadable. Now, these are similar triangles, so we can create a proportion out of them. So we know that if this length is to this length, just like this length is to this length, we can write that as a proportion of 3x minus 19 to x minus 3 as the same ratio as x minus 4 to 4. To solve this, we can use the cross multiplication principle, so that means x minus 3 times x minus 4 will equal 4 times 3x minus 19. And when we expand this, we end up with a quadratic equation, which we have just been learning how to solve these. So let's open this up. So we'll have x squared minus 4x minus 3x plus 12 equals 12x. Minus 76. Bring it all to one side, so you have x squared minus 4 minus 3, and then we're going to minus the 12 also. So that's going to be minus 19x, and then 12 plus the 76 will be plus 88 equals 0. So this might not be very easy to factor, however we do have the quadratic formula which allows us to find the answers to x. So that's negative b squared minus 4ac over 2a. And when you run that through, you have 19 plus or minus, let's see what's under the root here, 19 squared minus 4 times 88 is 9. That's a nice square root over 2. This means that this was actually factorable. So you could have factored this and found two numbers that multiply to 88 and have a sum of 19. In fact, that's actually quite easy to factor. If you see it now, product of 88, sum of 19, negative 19 would have been 8 and 11, negative 8, negative 11. But let's see if this actually gives us that to us also. This will be 19 plus or minus 3 over 2. So that'll be 19 plus 3, which is 22 over 2, which is 11, or 19 minus 3, which is 16 over 2, which is 8. So yes, that would have been the same thing. If we had factored it, we would have x minus 8 times x minus 11 equals 0. And so that's going to be x minus 8 equals 0, or x minus 11 equals 0, which is x equals 8 or 11. So both ways we get that, and actually if you can factor it, it is easier to factor it. See how much simpler that is than completing all this as well. So be flexible when you are solving. Here's another example. For over 2,000 years, the proportions of a golden rectangle have been considered visually appealing. Please Google this and check out some of these incredible proportions that are noticed in our world, not only in nature, but also credit cards, the ratio between the sizes of things that catch our eye. It's quite incredible. But this is the proportion that is used. The width is to the length as the length is to the sum of the width and length. So take a look at some clips for the golden rectangle as well. But let's say we just want to figure out what the length is on its own. So to solve that, so that length is on its own, we should manipulate this formula a little bit, and I'll show you how we could manipulate it. So cross multiply, that'll be L times L equals W times W plus L. So that's L squared equals W squared plus WL. And because we want to solve it for L, we should put it into the quadratic formula. Notice if there wasn't a square, then we'd get the terms together and factor them out. But if we get the terms together like this, so we can't just factor out a common factor of L, but we could factor, we could actually try to factor this, let's see, a product of -1 and a sum of -1. So is that possible? The only way to multiply to -1 is 1 times -1. That is the only way. And so if you add that up, that gives you 0. So this is not actually a factorable thing, but we can use the quadratic formula to find L by itself. So our A is 1, our B is -W, and our C is -W squared. This is in relation to L being our x. So we've got -b plus minus b squared minus 4ac over 2a. So let's simplify that, work a bit with that. So that's w plus or minus. That'll be w squared plus 4w squared over 2. And let's keep manipulating that over here. So we've got w plus or minus. Now what's in that root? Let's take the common factor out. So that gives us w squared, and then that's 1 plus 4. You could actually also see that as combining like terms. So that's actually 5w squared under the root over 2. Can we simplify that root? Well, split the root, so that's root 5 times w. The w comes out over 2. If we take out the w as a common factor, we get 1 plus or minus root 5 over 2. Now this here, if you did what I asked about Googling golden rectangle or the golden ratio, this number here is in fact the ratio that is used. So for example, credit cards, their length to width ratio, if you divide them, it'll be this number here. So check that out. Do a little bit of research, make a post. All right, here's another one. 2 ships leave a port at the same time. There's the port. One heads south, the other heads east. In several hours, we don't know how many hours, they are 170 miles apart this way. If the ship is traveling south 70 miles farther than the other ship, how many miles did they each travel? So one ship traveled X miles, one ship traveled X plus 70 miles. And so that's the distance, and that's the distance, and they told us the distance here. So because we don't know anything about their rates or their times, we can't make a rate-time distinction here, but we can look at it as a Pythagorean theorem situation. So here we know that x squared plus x plus 70 squared is going to equal 170 squared, according to the Pythagorean theorem. So now this is a quadratic equation that we can now solve using one of our methods. So let's expand this a bit. That'll be x squared. Using the perfect square trinomial, remember you can't just square both. It goes bracket times bracket, so it'll be x squared, and then the middle term is double the first times the last, so that's 140 x plus 70 squared, which is 490, and then 170 squared, which is a really big number, So let's get everything onto one side. We have 2x squared plus 140x, and then 490 minus the other number there is going to be negative 28,410 equals 0. I'm just going to divide everything by 2 to make the numbers a little smaller. We can do that because it's an equation. Now, because these are such big numbers, it'd be difficult to factor. So let's go ahead and use the formula that we have developed. So we could try to simplify this a bit, but we could also approximate it so that it's, because this actually doesn't simplify as an exact root, so we can approximate it to be 248.43. So if we add that to negative 70 and then divide by 2, we get 89.2. The other answer would be subtract that, so negative 70 minus 248. So that's going to be a minus number, so we're going to reject that number because it's not a possible distance. So the distance of one ship was 89.2 miles. The distance of the other ship was 70 more than that, which is 159.2 miles. Here's another example. We've got a mirror. The frame measures 14 by 20, and 160 square inches of mirror shows. Find the width of the frame. So let's see. Try to set this up and see what you come up with. So 14 by 20 is the outer part, and the x is the length of the frame. We know that the area of the mirror part is 160 square inches. So if we look at area, we need length times width. So we need this length and this, so this width and this length. So this will be 14 minus 2 x's, because there's 2 x's to take away, and this one will be 20 minus 2 x's as well. Area is length times width, so 20 minus 2x times 14 minus 2x will give you 160 as the area. So now you can go ahead and solve that just as before. So try it out and see if you end up getting what I get. So here I've divided by 4 so that it's easier to work with the numbers. Because this is a coefficient of 1, I'm just going to see if we can find a product of 30 and a sum of negative 17. Well, look at that. Negative 2 times negative 15 work well. So see, in this case, it's easier to use this than, easier to factor than using the formula. So you've got x minus 2x minus 15, and that would give you the same thing. So that's either x equals 2 or 15. So now let's consider that, see which one works. So if the width of the frame was 2 inches, that would make more sense than if the width of the frame was 15 inches. Is it even possible for this width to be 15? Well, if that width was 15, there's 2 of them, it'd be bigger than the size of the frame, so that's a reject. So with the width of the frame is 2 inches. Here's a formula example. We've got a compound interest formula to find the interest rate at which the principal of $10,000 will increase to $10,920.25 in 2 years. So let's plug in what we know and find out what the rate is. So we know that the amount that we will receive is $10,920.25. We know the principal was $10,000, and that was multiplied by 1 plus the rate squared. So this formula actually has already been developed for 2 years. Usually this is written as n for a number of years, because each year you're multiplying by 1 point something in order to get the rate increase. So the 2 is already covering the 2 years. So we just need to solve this. Let's first divide both sides by 10,000. Just so that it's possibly a little smaller numbers to work with here. However, this is quite a decimal. Okay, let's expand this. So we have 1 plus 2r plus r squared, and equals that. And let's subtract so that we can get r squared plus 2r, and then now we'll have 1 minus this 1.09 business. That'll be negative 0.092025 equals 0. Now this is definitely not very easy to factor, so let's use the quadratic formula. So now we have two options, either the positive or the negative. So the positive gives us 0.045 as the rate. That would make sense, 4.5%. The negative is going to be a negative rate. You'll notice that negative 2 minus the root of 4.3681 over 2 is going to be negative 2.045. And we know it's not a negative rate, therefore it has to be 4.5%. Okay, so we've got a sphere inside of a box, a cube, and they want us to express the surface area of the sphere as a function of the surface area of the cube. So this problem's a little more challenging. We need some variables though, because the surface area of the cube is based on some of the other measurements here. So the measurement I would choose to base everything on would be the radius, because we know how to find the surface area of the cube of the sphere based on the radius. Surface area of the sphere we know is 4 pi r squared from our formulas. We know that already. However, because they want it based on the surface area of the cube, this r is not the input they want. So we want to work on that r and see how it relates to the box's surface area, the cube surface area. So we'll come back to this and see if we can replace this r somehow in terms of s. So let's look at the surface area of the cube. How is that depending on r? And now surface area of the cube is actually big S based on how they've titled it here. So we know that the surface area of the cube is 6 of these panes, and each pane is length times width. But length times width in terms of r is 2r, right? Because it's 2 radiuses. 2r times 2r. So there's 6 panes of 2r times 2r, which is 6 times 2 times 2, which is 24r squared. So surface area of the cube is written as 24r squared. So if we could just get r by itself, then we could plug it back in here and have the formula that they have asked us for. So let's divide both sides by 24. We get r squared is equal to s over 24. Now remember, if we want to get r by itself, we have to take the plus or minus of the root of this. And again, let's rationalize the denominator. So that'll be multiplied by root 24. So we'll have root 24s over 24. 24, is that simplifiable here? 2 times 12, 2 times 6, 2 times 3. Yes, that's 2 root 6. So we can also write that as plus minus 2 root 6s over 24. And the 2 and the 24 cancel, so that's 12. Just some simplification going on. That'll be root 6s over 12 would be the radius. Now, could it be that the radius is negative? No. So we have to reject the negative version. So therefore, our r has to be root 6s over 12. So if we plug that in to our surface area of the sphere formula, we will get 4 pi 6s over 12, root 6s over 12 squared. Let's simplify that now. That'll be 4 pi, square that, top number will be 6s, bottom number will be 144, and simplify that with what we have here. So 4 and 144 simplify to 1 and 36, and 6 and 36 become 1 and 6. So everything simplifies to pi s over 6. So there you have it. The surface area of a sphere is pi times the surface area of the cube over 6. Yes, this one is a little more complicated, but it gives you an example of some of the tools that you have learned and how they come together to answer, say, a question like this.